Hello everyone, MK's here. This session I will be discussing very important sums on definite integration for your board examination. It's a very important topic in calculus. It has application not only in daily life, it has application in many other subjects. We'll solve those kind of sums which has daily life application and some problems which has application in other subjects. So without wasting our time, let us know what exactly you have to do for your board examination on definite integration. Unnecessarily you will not solve very difficult sums, that is never expected from you. As a student of applied mathematics, you will do the sums where application is directly involved with the concept of definite integration. When you are going to revise it for your board examination, you must remember the meaning of definite integration, that a to b fx dx. For a function which is continuous in the interval a to b, the interval is x greater than equal to a less than equal to b, a to b fx dx will represent the area of this portion bounded by with the x-axis. Function is continuous in this interval, the function is y equal to fx. So geometrical meaning of definite integration is that it will represent the area bounded by a curve with the x-axis. But not only with x-axis, the same manner you can find the area bounded by it with the y-axis. When you are going to find it with the y-axis, then you have to express x in terms of y, and the formula for that integration will be x multiplied by dy. If the curve is taken, say this manner, it's the curve, these are 2 points on the y-axis, you need to find this area. Coordinate of this point is 0, c and this point is 0, d. Then this area is represented by the value of this integrand c to d x dy. You have expressed x in terms of y, then use this. If you do it with x-axis, it will be a to b fx dx. This geometrical meaning concept you must keep in your mind. Then there is first fundamental theorem of integral calculus. For a function fx is continuous in this interval a to b, this a to x fx dx, this has another name, that is called area function. If this is the area function, then its derivative will be equal to the function fx. This is first fundamental theorem of integral calculus. What kind of sum is expected based on it, that let me explain. Question is given this manner: if y equal to this thing, find the value of x for which y is maximum or minimum. I told you maximum difficulty level of sums I will be covering here today. Easy sums you have already practiced, but these are bit conceptual sums, as first fundamental theorem included in your syllabus, second fundamental theorem of integral calculus also there in your syllabus. You know application of it in simple problems as well as in difficult problems. Let us start with this sum where the function given this manner, find the value of x for which it is this y is maximum. So here y is something like the area function, y equal to this thing. To get the value of maximum or minimum of a function, we need to compare its derivative to 0. How do I get derivative of this function? dy by dx. For maximum minima dy by dx is required. This dy by dx will be found out from here. It is a to x fx dx. So for this function you write dy by dx first. See the easiest application here, or just if you differentiate both sides, this integration sign will be removed and the variable will be in terms of x only. Don't keep t over there because the value x is here. So derivative will be like fx come out, here this thing will come out with t equal to x. So this will be x minus 1, x minus 2 whole square. Now for maxima or minima, you will put dy by dx equal to 0. This implies x minus 1, x minus 2 whole square 0. So x equal to 1 and x equal to 2. These are two values. Now whether there is maximum or minimum, the test you know. You just that second order derivative you have to find, or you have to go by sign change. I just remind you in this context, once you get these two values as x, those are critical values, then you go by sign of this function, which is dy by dx, which is x minus 1 into x minus 2 whole square. This function sign is not dependent on x minus 2 whole square, it is always positive, so depend on 1. Beyond 1, if you take any value, on the right side of 1 it is positive, here it is negative. So dy by dx at the point x equal to 2 don't change its sign, but at x equal to 1 it changes its sign. So this is the point of minimum over there. So the sum was asked in integration, but it is linked with maxima minima. With which theorem? First fundamental theorem of integral calculus. Keep this concept, this statement of the theorem in your mind. It might help you in examination. Maybe in short question, I have seen in many MCQ question, or it may be in 2, 3 or 5 mark questions. Next one is second fundamental theorem, which you are habituated with. You have applied in many problems, that if there is a function gx which is antiderivative of fx, or you can say that ddx of gx is equal to fx, then gx is called primitive or antiderivative. After integration a to b fx dx, you get gb minus ga. For example, if you want to integrate 1 to 2 2x minus 1 dx, how to find it? We will find its common integration first, which is nothing but 2x square by 2 minus x, then 1 to 2 upper limit lower limit, you substitute and get the answer. 2 square minus 2 upper limit, putting x equal to 2 and then 1. So answer is 4 minus 2, that is 2 minus 0, answer is equal to 2. Now when you are going to integrate this kind of thing, when I told you we will not do very easy sums, which you are able to do. This kind I showed you one, but these are the kind of sum where concept of definite integration linked with the concept of partial fraction. So to integrate this one, what we need to do first, we'll express this one as sum of two integrands. Let me show you, but as this is the revision class and final preparation for your board examination, I'll be bit faster than normal. So let us apply the concept of partial fraction here. Let x by x plus 1 into x plus 4 equal to a by x plus 1, b by x plus 4. I'll use second fundamental theorem, but we need to integrate this first. Then you cross multiply and then compare x plus 4 b into x plus 1. A, b we have to get. How to get a and b? Put x equal to minus 1 on it and then put x equal to minus 4. For minus 1, what do you get? Minus 1 equal to 3a. So a will be minus 1/3, and for minus 4, for x equal to minus 4, you get minus 4 equal to b into minus 3. Therefore b equal to 4 by 3. After getting these two, a and b, the integrand given over there, this integrand we are writing now 1 to 4, a is minus 1/3 dx by x plus 1 plus 4 by 3 1 to 4 dx by x plus 4. You all understand? So here on integration minus 1/3 will come out log x plus 1, this plus 4 by 3 outside log x plus 4. Nothing is negative, so we need not put minus sign over there. In both the cases, limit going from 1 to 4. Here also from 1 to 4. The value going to be minus 1/3 log 5 minus log 2. This plus 4 by 3 log 8 minus log 5. Just little bit simplification will tell you the answer. You all can easily simplify it. Maximum what you can do here, you keep minus 1/3 outside log 5 by 2 plus 4 by 3 outside log 8 by 5. This is the final answer. Alright. So you all understand, you have actually revised the concept of partial fraction also, isn't it? Now let us go for the second sum. This is direct application of formula. You will remember the formula for indefinite division: x root over x square plus 4 by 2 plus a square by 2 log of mod of x plus x square by 4, 0 to 2. You put upper limit first, 2 root 8 by 2 plus 2 log of, put x equal to 2, 2 plus root 8 minus 2 log 2, because x 0, x square also 0. So here the final answer going to be 2 root 2, 2 to get cancelled, plus 2 into log of root 8 is 2 root 2, 2 plus 2 root 2, and this 2 also will be there. So the answer is 2 root 2 plus 2 log of 1 plus root 2. Alright. For next one you need to divide, you need to reduce and then integrate. I'll do it. So go by dividing x square by x minus 1 into x minus 2, which is nothing but x square minus 3x plus 2. So x square, if you divide by, this is x square here, 1 if you take, so if you subtract, there will be 3x minus 2. So this integrand can be written as 3 to 5 1 plus 3x minus 2 by x minus 1 x minus 2 dx. Alright. Now you split this one as the sum of two integrands. So this one will be x, the first part, limit 3 to 5, and this one 3 to 5, 3x minus 2 by x minus 1 into x minus 2 dx. I am not going to complete this sum because this sum is like previous one only. Why I have chosen this one for revision? Because if the integrand is of this form, you have to divide, you have to reduce the denominator, its degree should be less than the degree of numerator should be less than degree of denominator, and then proceed to use partial fraction. This one you can easily complete. Next we are going to do 0 to 1 e to the power x, 1 plus e to the power x. Obviously this sum going to be on substitution, and this sum I have chosen to remind you that integration sometimes you have to do by substitution in definite integration also, but never forget to change the limit. Limit you never forget to change. So what is the substitution you are going to do there? Let 1 plus e to the power x z, so e to the power x dx is dz. Now when x equal to 0, z equal to 2, when x equal to 1, z equal to 1 plus e, isn't it? Now just substitute the values. Do not forget to change the limit. This is going to be what? 2 to, because z is 2 for x equal to 0, 2 to 1 plus e to the power x dx is dz. So this part will be replaced by dz. It is root z dz. Alright. So this is nothing but z to the power 3 by 2 by 3 by 2, 2 to 1 plus e, 2 by 3, put the upper limit first, 1 plus e to the power 3 by 2 minus 2 to the power 3 by 2. No need to simplify, keep your answer this form only. This one what to do, you go by parts. This one is the first function and dx is the second function. So log 1 plus 2x, dx integration is x minus x by 1 plus 2x into 2 dx. Limit you never forget to put. This rule of integration you know very well. This dx taken first function, its integration is x, here also x. Derivative of log of 1 plus 2x is 1 by 1 plus 2x into 2. Now this part is finished. This part if you put the value 1 into log 3 minus 0, minus this part is what? 0 to 1 2x. 2x is 2x plus 1 minus 1 by 2x plus 1 dx. So there it will be log 3 minus 0 to 1 dx separate, this by this, plus 0 to 1 dx by 2x plus 1. So this thing is log 3, this thing is x, so 1 minus 0, and this one is dx by ax plus b. I told you in the earlier class that 1 by a log of mod of 2x plus 1. Limit of integration 0 to 1. So this thing going to be log 3 minus 1 plus half. Log 1 is 0, so we need not take it. So it is 3 by 2 log 3 minus 1. Alright, because half is there. So we have to take half into consideration. And 1 log 3 already there. Okay. So the answer is this. Now for next one again a sum on partial fraction. But let us do it because these are important sums that substitution you have to make here. On the substitution then it will be changed to simpler form. Let me do it. This thing, what substitution you are going to make? Here the substitution will make x cube equal to, or t cube equal to z. So let t cube equal to z. So 3t square dt equal to dz. Change the limit when t equal to 0. When t equal to 0, z is equal to 0. When 1, z is 1. So it is dz by 1 plus z, 2 plus z. Some of you might have done this one without partial fraction. In fact, when two consecutive terms are there in the denominator, without using partial fraction you can do it. You can write this one as 1 by 1 plus z minus 1 by 2 plus z, and then upper limit, then integration sign will be there, of course, this thing dz. So first integrand is log 1 plus z minus log 2 plus z. Limit now you write here. Put the upper limit, log 2 minus log 3 minus lower limit log 1 minus log 2. So there will be this upper limit, no, that x equal to 1. It is log 2 minus log 3 whole of upper limit, then log 1 minus log 2. Now this is log 2 and plus log 2. So 2 log 2 is there minus log 3. What is this? So 2 log 2 is log 4. Log 4 minus log 3. Answer is log 4 by 3. Now we need to know some properties. Some properties of definite integration included in our syllabus. Let me remind you. The definite integration value independent of change of variable. If you change the limit, I mean a to b to b to a, you have to put a negative sign over there. Then if you, as definite integration is area, so area between a and b is area between a and c plus area between c and b, where c is a point lying in between. Number 4, a to b fx dx is a to b f of a plus b minus x dx, and 0 to a, which is actually another form, another statement of this one. By taking upper limit a, lower limit 0, it can be stated this only. But still, itself has a very good application. Many applications are there, in fact. So that's why you need to know these two separately. 0 to a fx dx, 0 to a fx dx, and 0 to a minus x dx. Okay. Now the next property is if f of 2a minus x equal to fx, then this fx will be added to this fx, it will give you 2 0 to a fx dx. And 0 if f of 2a minus x equal to minus fx. So knowing this one is important, but for application number 7 is also very important. And the 8th one, minus a to a fx dx. If fx is even function where this property is obeyed, that f of minus x equal to fx, then it will be 2 into 0 to fx dx. But this is the case of odd function, f of minus x equal to minus fx, then the value of the integrand will be equal to 0. Okay. So let us apply in solving sums based on it. When we are going to do number 1, minus 4 to 4 x plus 2 dx. How to integrate this thing? Minus 4 to 4. You need to know the interval where the mod function is positive or where it is negative. Then you can proceed easily. So when you are going to, just a minute, when you are going to write mod x plus 2, when you are going to plot in number line, it is better if do in details, draw the number line in your board paper, it looks good. So you will write it this manner. The critical point here for which it vanishes minus 2. But other points are there, minus 4 and 4. Okay. Before minus 2, mod x plus 2 negative. So minus 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 here and plus 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 here. So this sum, when you write in the form, say minus 4 to minus 2, it is negative, and then minus 2 to 4, it is positive, x plus 2 dx. Now just ordinary integration, minus x square by 2 minus 2x, minus 4 to minus 2 plus x square by 2 2x minus 2 to 4. Just here you put upper limit minus lower limit, x equal to minus 2, that minus 4 by 2 plus 4, this minus 16 by 2 minus 8 plus 8 plus 16 by 2 plus 8 minus 2 minus 4. So the answer going to be equal to finally 2 minus 0 plus 8 plus 8 plus 2. Numerical calculation you do better than me. You must write, if I get any question, any answer a little bit mistake over there, you must mention it here. Now let us do next one. This kind of sums are important in definite integration. Properties we are applying, the property we have used here, this is the third property, splitting the integrand in sum of two integrands. For this one, number 2, what to do? It's a very good sum. Again you go for drawing the number line. Critical points are 2 to 4. You write the value of function before 2, both are negative. So minus of x minus 2 minus of x minus 4, value is minus 2x plus 6, and beyond 2 it is x minus 2 positive minus x minus 4 on simplification 2, beyond 4 x minus 2 plus x minus 4 to x minus 6. So again you go for splitting. How many critical points are there? There is a point 1, there is a point 5, and in between all these come. So the integrand, if you want to write, then the integrand going to be 1 to 2, first interval. It is minus 2x plus 6. Then 2 to 4, the second interval, the function is 2 dx. And then plus 4 to 5, 2x minus 6 dx, finished. Now go for integrating this function, then put upper limit minus lower limit, then the sum is done. So you all must complete it. If any difficulty arises, you must mention it. I am not going to complete the sum here because this concept all of you have it. This is the time to revise all the concepts. How to do number 3 here, 0 to 3 modulo x dx. Modulo function 0 to 3. So here that modulo function is step function, greatest integer function, interval to interval its value changes. So this one you write as sum of 3, 0 to 1 modulo x dx plus 1 to 2 modulo x dx. Because it is discontinuous at those points, that's why we are taking this final. And the next interval will be plus 2 to 3 modulo x dx. So here the value is 0 dx. In between 1 and 2, the greatest integer is 1. Here one important, very important concept I would like to say, when you are writing 1 to 2 fx dx, then actually here this limit x is going to be greater than or equal to 1 less than 2. Please keep this in your mind, it is very important. 2 not included. So 1 to 2 the greatest integer going to be 1 only. 1 to 2. 2 to 3 greatest integer not 3, it is 2. So it will be 2 to 3. This part is 2 only, 2 dx. Now you just integrate, it is 0, it is dx, x integration, it is 2x, 2 to 3, 2 minus 1 plus 2 into 3 minus 2, 1 plus 2 into 1, answer is equal to 3. Alright. Now let us do this sum, number 4. Number 4 is a very challenging sum, very good sum, very important sum. What else can I tell you? It's a nice sum, very important. The concept, we are working on mod function. So this will be justified to complete the sum like mod of x cube minus x also. First thing, when you are going to do it, when you are going to answer number 4, you will be writing x cube minus x as product of 3 factors. You understand? It is x, x plus 1, x minus 1. Now tell me that this sum and the previous sum, is there any difference? There it was sum of 2, here it is product of 3. And the interval, if you plot the number line here, this interval going to be 1 to 2 given. Here it is minus 1, 0, 1. Integrate -1 to 2 given, 2 also you must write this method. Now go by sign change again. Before -1, okay, you go on putting those plus and minus signs. As you know it, that 1 is the largest one here, 2 is for integration purpose, 2 has no other link. So first step, what I have to do there, I have to write the sign of this function, the given function, the given integrand over these intervals. What are the intervals? -infinity to -1, -1 to 0, 0 to 1 and 1 to infinity. And you know, greater than the greatest one, the sign is always positive. So put plus signs. Then alternate plus minus, because indices are all odd. Plus, plus, and here minus. Now this one is just a one-step sum. Why? Because now we'll write this integrand as -1 to 2 as -1 to 0 till 0, it has the same sign. -1 to 0 it is positive. X cube minus x dx. 0 to 1 it is negative, you write x minus x cube dx. And here it is again positive, you write, now you write this one also, 1 to 2 x cube minus x dx. Alright, now integrate, put upper limit minus lower limit, the problem will be solved. Okay. Now for the fifth problem, 0 to 1, you write it in this manner, 0 to 1 log of 1 minus x by x dx. Then use the fourth property. What is that? 0 to a fx dx is 0 to a f of a minus x dx. So this thing can be written as 0 to 1, 1 minus this divided by 1 minus x dx. So if I have taken this one as I, then this thing equal to, I equal to this thing also. That is 0 to 1 x by, sorry, log sign is there. Log of x by 1 minus x dx. Mod sign you can put, if it is not given then also you can put. So you have started with this function, what is given over there, and by using this property 0 to a fx dx equal to 0 to a f of a minus x dx, you got the same thing over there. Now add this and this. So I plus I going to be what? It is 0 to 1 log of 1 minus x by x plus log of x by 1 minus x whole thing dx. So this is nothing but 0 to 1 log of a plus b is log ab. If you multiply these two, result is 1. Log 1 is 0. So 2i equal to 0. This implies that I is equal to 0. I hope all of you have understood. Next one, for number 6. For number 6, it's a very interesting problem, that a to b, the third property you go through, that minus, I know, a to b fx dx is a to b f of a plus b minus x dx. So this you take I equal to minus 3 to 3 x square by 1 plus 5 to the power x dx, or what is a here? Minus 3, b is 3, so a plus b 0. So a plus b minus x, if you want to write, is minus x only. So minus 3 to 3, x you replace by minus x. This is mathematics. Here you got very interesting form, no? minus 3 to 3 x square by, this is 1 plus 1 by 5 to the power x dx. This by 5 to the power x plus 1 dx. Can you see something over there? This I and this I, what you got in 1, you have started with 1, now you have reached 2. You just add these two, I plus I minus 3 to 3. If you add, see the denominator has the same value. Numerator x square, if you take common, these two get cancelled. So minus 3 to 3 x square dx, which is nothing but x cube by 3 minus 3 to 3, 27 plus 27, 54 by 3, 18. So 2i equal to 18. This implies I equal to 9. Alright, you all understand? Next problem, number 7. You see, this one is an odd function. For odd function, what is the property left over there? X to the power 23 is an odd function. If you take fx equal to x to the power 23, f of minus x is minus x to the power 23. So it is an odd function. It is minus fx. Directly you write its value equal to 0, but you must show how f of minus x equal to minus fx for your board examination. So this has value 0. Another question where we are going to apply the fourth property. Fourth property mostly used. This you need to keep in your mind. So for number 8, what you are going to do? I equal to 2 to 8. Fourth one, that is given as third property. What worksheet I have shared with you, x plus 1, 11 minus x dx. So what is a here? 2, b is 8, so a plus b equal to 10. So this you write, or I equal to 2 to 8, 2 plus 8, 10 minus x, you are replacing by 10 minus x. Here also x you are replacing 10 minus x plus 1. Alright. So I is going to be 2 to 8 root 11 minus x. 11 minus x plus under root x plus 1. I mean 1 plus x. See the fun here. This is number 1, number 2. You just add 1 and 2. I plus I. Same denominator, same numerator is coming on addition. Result is 1. That is 2 to 8 dx. X. Answer is 6. Therefore, I is equal to 3. Next one also we are going to apply this property. 0 to a fx dx is 0 to a f of a minus x dx. So this you write, let this be equal to I. So I equal to 0 to 1, x you replace by 1 minus x. So I is equal to 0 to 1, x to the power 5 by 2, 1 minus x dx. Now multiply and separate. Okay. So this will be x to the power 7 by 2 by 7 by 2, 0 to 1. And this one will be x to the power 9 by 2 by 9 by 2, 0 to 1. 2 by 7 minus 2 by 9. Okay. So this kind of sums always important. You must practice it properly before exam. The next type of sum from definite integration I am going to discuss with you how to get the revenue function from marginal revenue or cost function from marginal cost, all these things. Marginal revenue given, you have to get the revenue. This kind of sum always important. So how to proceed for this one where marginal revenue given as 40 minus 10x square. You all know the formula of marginal revenue. So it is for this sum, it is marginal revenue dr by dx is 40 minus 10x square. You cross multiply and integrate. So dr is 40 minus 10x square dx. On integration this will give you r. This one 40x 10x cube by 3 plus c. This plus c you can get by using the information given here. When x equal to 3, you know r equal to 120. Therefore, 120 equal to 40 into 3 minus 10 by 3 into 27 plus c. This implies that this is plus c. Okay, plus sign is there. So c going to be equal to 90. No, 3, 9. Yes, 90. So revenue function Rx is now 40x 10 by 3x cube plus 90. Alright. Now let us find the marginal cost from the marginal cost function given over there. For this one, marginal cost you write in the form that which is nothing but that dc by dx, no? You write dc by dx equal to x by under root 2500 plus x square. So integrate both sides. dc equal to x dx by under root 2500 plus x square. Now for its integration, put 2500 plus x square equal to z. On putting plus x square equal to z or z square as you like. If you differentiate, 2x dx equal to dz. So on integration this will give you c, and there it is dz by 2 root z. So 1 by 2 outside, z to the power minus half dz, 1 by 2 z to the power minus half plus 1 by this plus c also you have to take this plus c. No, as you have taken cost function as c, you write cx, no problem, but here the integration constant you write plus k. Alright. So now cx is changed to what? Cx is changed, so this is half get cancelled. Root z is x square plus k. Now when x equal to 0, cx equal to 1000. So the value of k coming to be 1000 minus 50, that is 950. So what is the cost function for this problem? The value of k you got. The cost function for this problem, for this sum number 2, is going to be cx equal to root 2500 x square plus 950. Alright. For the third sum, number 3, that dc by dx equal to x root x square plus 1. So cross multiply and integrate x square plus 1 dx. Now for this integration you need to make a substitution here, that root x square plus 1, I mean x square plus 1 you take, this is equal to z square or z as you like, x dx equal to z dz. So c or cx, if you write cx, it will be justified because it is a function of x. This is going to be x dx is z dz, z into z dz plus k. So z square z cube by 3, this plus k. So cx, now you put z, z is x square plus 1 to the power 3 by 2 by 3 plus k. Now for this sum, no initial condition given, cost of producing 3 units. So you put when x equal to 3, cx is 7800. Get the value of k from this condition and cost function can be found out like the previous sum. Let us complete this kind of sums by solving number 4. Don't be confused by seeing such a big sum. It is not a big sum at all. They have asked you to find marginal revenue. Given you find the revenue function. How to proceed? You have to write dr by dx, marginal revenue. This is nothing but this x plus 3 whole square. You can write the numerator. This 5x square plus 30x plus 51. Here revenue function given. You have to show that, I mean derivative of revenue function given. You have to show that revenue function is this. So you need to integrate. We need to simplify it. You write 5x square plus 6x and this thing 5x square 30x is over, then write plus 9 45 plus 6. So this integrand you write, I mean dr by dx you write in this form first, x plus 3 whole square plus 6 by, alright. So rx, when you are going to write it will be 5, you separate it, 5 plus 6 by x plus 3 whole square. So rx is integration of this thing, dx by x plus 3 whole square. So this you write rx equal to 5x, this one integration will be x plus 3 to the power minus 2 plus 1, this plus c. So rx equal to 5x minus 6 by x plus 3 plus c. No revenue is there when no input is there, isn't it? So for x equal to 0, rx equal to 0, use this condition. Now for x equal to 0, rx equal to 0. So 0 equal to 0 minus 6 by 3 plus c. So the value of c is equal to 2. So Rx going to be what? This plus 2. You go on simplifying it. The value of C is 2 only. Plus x plus 3 you take LCM. These two get cancelled. 5x plus 2x by x plus 3 is the revenue function. You are asked to show that only, show that revenue function is this. we got it there by actual calculation. Revenue function is 5x plus 2x by x plus 3. Next part of application is consumer surplus, producer surplus. You have practiced sums. I just remind you what is that, how to calculate it quickly, what technique you will follow when you are answering question from there in exam. Firstly, you have to understand what is demand curve, what is supply curve. I mean, in the problem it will be given that demand curve and what is supply curve, there it will be given, and what is equilibrium, and both of them are function of quantity, price. Okay, both the price is taken along y-axis, quantity taken along x-axis. So demand function represents the quality of good or service that consumers are willing to buy at a given price P. It establishes the relation between price and quantity demanded. Supply function, quantity of good or service that producers are willing to sell at a given price P. It will also establish a relation between price and quantity supplied. Consumer surplus, this is very important. I hope you have understood. I just remind you. This is the measure of economic benefit consumer receive when they buy a good or service at a price lower than maximum price they are willing to pay. They are willing to pay, but they have some surplus. It is represented by area bounded by this with the price axis. Very important. Don't forget. So this is demand curve. At the equilibrium point, the demand curve makes some area with the price axis, that is consumer surplus. Please don't forget. But its calculation, we have different method. Without finding area with y-axis, we can find. That I will tell you. Producer surplus is what? Is the measure of economic benefit producers receive when they sell a good or service at a price higher than minimum price they are willing to accept. It is the area between the supply curve and market price up to the quantity sold. Okay? So this part, this yellow part is producer's surplus. Now equilibrium price is what? That equilibrium price is the market price at which consumers are willing to buy exactly same quantity as producers are willing to sell. That is equilibrium price. Okay? Now, equilibrium price is found by calculation, by making supply function, demand function same. How to get consumer surplus? By using the concept of definite integration. If I tell you this part P0, this part Q0, and this point as A and this is origin. This point is B, this point is C. Area of OBAC is what? This is Q0 and this part is P0. It is simply P0 into Q0. Equilibrium price and equilibrium quantity, they are multiplied. Now consumer surplus, when you are going to find, you integrate demand curve from 0 to Q0. I mean, you will get this whole area. This point, if you take D, you will get the area ODA Q0O. From there, you subtract the area of the rectangle. That's why consumer surplus going to be equal to integration of demand curve. I am writing this way. Demand curve integration minus area of OABC, that is P0 Q0. Okay, so this area you get by integration, this area, this to this. From there, this part you subtract consumer surplus. Similarly, to get producer surplus, you consider the area of this rectangle. From their area bounded by supply curve, you subtract. So producer surplus is going to be what? Producer surplus will be integration of supply curve between what to what? Between 0 to Q0. Here also between 0 to Q0. Okay, and this you subtract from area of the rectangle. So producer surplus will be P0 Q0 minus integration of supply curve. Okay, let us apply this concept in solving few sums. In my worksheet, which I intend to upload in the description box, I have solved some sums over there. I have uploaded. I'll upload it. Okay. But some problem I'll show you. First one, demand function given. You have to find consumer surplus. Find the consumer surplus, market price given, and consumers buy 40 units, it is given. And second sum, supply function given. Okay, let these sums you will find there in the problem sheet. Let me solve some unsolved problem before your board examination. Okay, I'll show you, maybe solved somewhere, but I am going to show you before your examination in details. Find the consumer surplus for demand function. This when P0 is 90. No, not this one. I would like to show you these two sums mostly. Okay, like number 4, 5, 4 and 5 I will solve it for you, but one sum of this kind also let us solve. Let us solve one sum of this kind first. This number 1, consumer surplus. Okay, when this thing is given, this is actually a type, no, that's why I cannot solve only difficult sum. Let me remind you the concept behind this sum here. Just read the sum. Consumer surplus for the demand function is this. You have to find consumer surplus for this demand function when P0, that equilibrium price, is 19. So very first step, what you will do there, you will find the equilibrium commodity, I mean the value of X. So this P you replace by P0. So 19 equal to 25 minus X square. This implies X square plus X minus 6 equal to 0. So X plus 3, X not equal to minus 3, so X equal to 2. So P0 they have given, now you got Q0. Q0 is 2. Now just I remind you that demand function. Just we did it, I just remind you once more. That supply function not given. But you got equilibrium price. This portion you can find easily. This portion you can find easily. How? Because you got that value of X is equal to 2 here, and this portion also you got 19. Now this curve is 25 minus X minus 6 square, and this part is called consumer surplus. Which part? The part above it. I showed you earlier. So this portion is consumer surplus. How to get it? What is the method? This portion, this total area we will find, we will integrate from 0 to 2. From there we subtract this area. Just I told you 19 into 2 we will subtract. So this thing is going to be 0 to 2. 25 minus X minus X squared dx. This minus 2 into 19. Okay, you just simplify it to get the answer. That will be the value of consumer surplus. In my calculation I got 22 by 3. You check with your own calculation. Next one, demand function for a commodity is given, that is 10 by X plus 1. Find the consumer surplus when the prevailing market price is 5. Same manner. What you will do here? they have given prevailing market price. It means the value of P0 is 5. So 5 equal to 10 by x plus 1. This implies x plus 1 2. So x is equal to 1. So Q0 equal to 1 and P0 equal to 5. Alright. Now again the same manner you find consumer surplus. This is just another example, nothing else. Just another example. CS going to be what? Integration of this from 0 to 1. That 1 is the equilibrium commodity, 10 by x plus 1 dx. This minus P0 x0, that is 5 into 1. So just simplify it, 10 log x plus 1 minus 5, 10 log 2 minus 5. Alright, I hope all of you have understood. The same manner you will be solving number 3, but here it is given supply function. Here it is given supply function P equal to x square plus 4x plus 5. Find the producer surplus when price is 10. So you compare that P with 10. Proceed the similar manner. Just put P equal to 10 over there. So 10 will be equal to x square 4x plus 5 minus 5 equal to 0. So x plus 5, x cannot be minus 5, so x is 1. So how to get the producer surplus? Same manner you integrate. Now you find P0 x0. This x means actually x0 and P0 is what? 10. So P0 x0 1 into 10 minus 0 to 1 x square 4x plus 5 dx. So 10 minus this, on simplification I got 22 by 3. This is coming to be 8 by 3. Check my answer with your calculation. Alright. Now let us do number 4. A very good sum. And number 5 also a good sum. Let us see how to solve it. 4 and 5. Demand function given and supply function both are given here. So I'll tell you the simple technique to solve this problem. Okay, you have little bit idea of definite integration, how to apply it in find consumer surplus, producer surplus. So your first thing will be to plot the graph of these two, rough sketch. Demand function, supply function, you keep that manner the way I showed you. Even you are wrong in drawing it, it doesn't matter. You just draw a shape over there which will help you to better calculation. So this part normally Q or X and this part we take price. Here it is given demand function like this, supply function is like this. It may be straight line, whatever, it doesn't matter. So this part is going to be CS, the consumer surplus, and this part is going to be the PS, this portion. This is equilibrium price. This part is A, this one B, O, this one we take C. Here it is Q0 or X0, here it is P0. Bas, done. We can get P0, Q0 very quickly. How? At the equilibrium, demand function is equal to the supply function. So minus 2Q plus 14 is going to be equal to Q plus 2. This gives us Q equal to 4. By putting Q equal to 4, P is coming to be 6. So consumer surplus, this part we are going to find. Another thing we will do, we will write the demand function here on the side of this, and here we will write the supply function Q plus 2. So your integration will be easier. When you are going to find this consumer surplus here, that will be given by CS equal to This is what? This you got 4. Which one you got 4? This q0 equal to 4 you got. This you got 6. So you integrate which function? This minus 2q plus 14 dq, and from there you subtract the area of this portion. This is 6 into 4, 24. On integration I got the answer here 16 as consumer surplus. You check, okay, just common integration, or I do it, I can do it, no problem. This integration is going to be minus q square 14q upper limit. So this is coming to be 16. It's correct. Producer surplus, how do you get? I mean area of this portion. Then we need the concept of this supply curve. Q plus 2. And the area, from this area you subtract this one. This portion area you have to subtract. So you write P0 Q0. From there you subtract 0 to 4 q plus 2 dq. So this is 24 minus. So the answer is going to be equal to, this is equal to 8. Alright. The next one, that number 5. Number 5 I have taken because one quadratic function is there. But whatever quadratic, linear, whatever there, you find in equilibrium what is happening. This is demand function, supply function, consumer and producer surplus. So for equilibrium you write dq equal to SQ. This implies 1000 minus 25q equal to 100 plus q square. Q square so this implies q plus 45 so q is equal to 20. Alright. Now find the corresponding value of dq, the demand function corresponding value. dq going to be what? 1000 minus 25 into 20. So this thing will be 1000 minus 500, that is 500. Now you find producer surplus. This will be 500 into 20, the area of that portion. From there you subtract 0 to 20, the demand, the supply function. Alright. And consumer surplus 0 to 20, this demand curve integration minus area of that portion. The answer I got here is approximately 5333, and here the answer I got 5000. Check it once. So I have tried to explain the concept of definite integration, the formula, the properties, application in daily life. Now the problem sums I am sharing with you. If you can practice, you will remember all these topics in your exam. Let's hope for the best.